Good morning, students. This is Murthy sir. Today I would like to discuss with you the synthesis of some chemicals from sodium chloride. Sodium chloride can be used as raw material for the synthesis of some chemicals, and also the concept of water of crystallization. Let us see first the synthesis of sodium hydroxide and calcium oxychloride, commonly called bleaching powder. Let us see the chemical reaction. Sodium chloride reacts with water to form sodium hydroxide, and chlorine and hydrogen gases are formed in this chemical process. This process is popularly called chlor-alkali process. Chlorine gas is collected at anode and hydrogen gas is collected at cathode. These two are positive and negative electrodes. Sodium hydroxide is a strong base which can dissolve in water. So bases which are soluble in water are called alkalis. That's why this process is popularly called chlor-alkali process. Chlorine gas is produced in this chemical process, and sodium hydroxide which is formed is an alkali. So they named chlor-alkali process. And the chlorine gas that is formed in this chlor-alkali process can be used for the synthesis of bleaching powder. Let us see how. Chlorine reacts with lime water, calcium hydroxide, to form calcium oxychloride, CaOCl2. It is popularly called bleaching powder, and water is also formed. This bleaching powder is commonly used as disinfectant. Let us see another chemical process, the synthesis of baking soda and washing soda from sodium chloride. So in this chemical process, sodium chloride reacts with water and carbon dioxide and ammonia to form ammonium chloride and sodium bicarbonate. So here four reactants are there. Sodium chloride is reacting with water, carbon dioxide and ammonia. The products formed are ammonium chloride and sodium bicarbonate. Sodium bicarbonate is commonly called baking soda. This baking soda, when you supply heat, it turns into sodium carbonate, water and carbon dioxide. Sodium carbonate is popularly called washing soda. And let us see the concept of water of crystallization. The presence of a fixed number of water molecules in the crystal lattice of a salt is called water of crystallization. The examples are washing soda. It contains 10 water molecules, Na2CO3, 10 H2O. Another example is hydrated copper sulfate, CuSO4, 5H2O. Copper sulfate contains a fixed number of water molecules, 5 water molecules. Gypsum, it contains 2 water molecules. Calcium sulfate, and it contains 2 water molecules, CaSO4, 2H2O. Plaster of Paris, it contains half water molecule, CaSO4, half H2O. So all these are examples for water of crystallization. They are all hydrated salts. If the salts contain water molecules in their crystal lattice, they are called hydrated salts. And if you supply heat and when the water evaporates, they turn into anhydrous salts. Here let us see one experiment related to water of crystallization. Here the apparatus says you had to take one test tube. In that we had to take copper sulfate crystals. It's a salt. It will be in blue color. And you have to hold the test tube which contains copper sulfate crystals with the tongs. And you have to supply heat with the help of a Bunsen burner. So when the flame touches the test tube, slowly the water molecules present in copper sulfate, they evaporate, and you can see the formation of water droplets on the sides of inner wall of test tube. And after some time, when you add 2 or 3 drops of water again to the copper sulfate, it regains its blue color. So here one important color change we will observe. When hydrated salt loses its water molecules because of heating, it turns into anhydrous salt. So here blue colored copper sulfate turns white in color. And again, when you add 2 or 3 drops of water molecules, when you moisten that, then it regains its blue color. So because of heating, copper sulfate is turning white in color. Water molecules are evaporating and it is turning white in color. Again, when you moisten that, when you add 2 or 3 drops of water to that anhydrous salt, it turns blue in color again. So this is one experiment. Here one tongs is required to hold the test tube. So clear color change can be seen. Students, related to the concept of acids, bases and salts, we will discuss the remaining portion in the next class. Thank you. We'll meet again.